Over the last 2 decades, scientists have found thousands of planets elsewhere in the universe. These are called exoplanets. As we get better and better at finding them, we need ways to narrow down the ones most likely to support life. 2 NASA rocket teams are working to do just that from Australia. Their mission? Study a special pair of stars best seen in the southern hemisphere and propel humanity's search for habitable worlds into the future. I'm Miles Hadfield, and I'm following these rocket teams to Australia to show you what it takes to launch a rocket and make groundbreaking scientific measurements. Hang on tight. We're going on an adventure, high above, down under. Earth is packed with life. But some environments are more habitable than others. So what makes an environment, or a planet, a good place for life to thrive? Well, one thing is water! And in fact, that's what the search for life elsewhere in the universe is focused on so far. Finding planets where water can exist in liquid form. There's a region around every star that scientists call the Goldilocks zone. A planet in this zone has the right temperature for water to remain liquid. Too close, and the water will evaporate away. Too far, and it'll freeze. The distance has to be just right. This zone has been the basis for the search for habitable worlds. But just because a planet is inside the Goldilocks zone doesn't mean it can sustain life. Take, for example, the closest known exoplanet to Earth at just 4.2 light-years away. It's located in the Goldilocks zone, but scientists think the star's frequent eruptions might have blown away any atmosphere the planet might have had. In other words, the Goldilocks zone is just a first guess. To truly tell whether an exoplanet is habitable, we need to look at the star it's orbiting.
Unfortunately, we can't just observe a planet and understand it at face value. We have to understand it in the context of what its parent star is giving it.
So scientists have been collecting data from different types of stars to learn how they affect their planets.
We would like to be able to create a menu of star-planet possibilities that our future missions can draw from and prioritize the most promising places to find habitable environments.
The next item to be added to the menu? Yellow stars. We're looking for something around 5 billion years old, an average size. Wait a second, don't we have one right here? So why not use the sun?
We've thought that our sun is the prototype for kind of 5 billion year old average yellow stars. What we've learned recently is that our sun is actually quite inactive for a 5 billion year old yellow star.
Typical Earthling behavior, really, thinking we're the example for the entire universe. But it turns out yellow stars are found throughout our galaxy, and they tend to erupt with life-altering activity more often than our sun does. So, if we want to understand if they can still support life, we'll need more data than our sun can give us. That's why 2 rocket teams are looking to Alpha Centauri A and B.
The reason why we're targeting Alpha Centauri is that it's our nearest solar twin. So
Counting rockets, they'll capture light from those stars that doesn't make it to the ground. This range of highly energetic ultraviolet light has never been measured before for these stars. Even small differences in this UV light from a star can determine whether a nearby planet can support life or not. But the Alpha Centauri system isn't visible from most places in the US. It's best studied from the southern hemisphere. That's why we're here in northern Australia, in the traditional homelands of the Yolngu people. They've been observing the stars here for tens of thousands of years. I'm here with 2 rocket science teams, Sistine and Deuce, and a crew of about 50 NASA engineers, rocket specialists, and support staff. In partnership with Equatorial Launch Australia and the Gumatch Corporation, they've created an entire rocket range from scratch to help the scientists achieve their goals. In this series, you're going to meet these teams and follow their quest high above the Australian outback to see what it takes to make these first-ever measurements from our closest stellar neighbors. We're going behind the scenes to learn more about the science of habitability and what goes into launching a rocket, dodging venomous snakes and crocodiles along the way. But first, we'll take a look at how this brand new rocket range came to life with the help of the Yolngu people, who have been observing these stars for millennia.